Hi kids. So in this video we are going to look at the chord properties of circle from class 9. In this video I'll discuss the theorem and we'll do the proving of the theorems in this video, okay? Just look at the first theorem on chord properties of circle. First thing which comes into mind, what is a chord? We all know a line segment joining two points on the circumference of a circle is known as chord, and we know that diameter is the longest chord in a circle. Now let us see the first theorem on chord properties of circle. I'll just write this statement first. Okay, the theorem says a straight line drawn from the center of a circle to bisect a chord, of course not the diameter, is perpendicular to the chord. This is the statement. Let us see the meaning of this. What I mean, if you take a circle, okay, suppose O is the center, you take a chord, suppose your chord is AB, and you draw a line, suppose OM, such that AM is equal to MB. See, a straight line drawn from the center of a circle to bisect the chord, which means this and this will be same, is perpendicular to the chord, which means if AB equals to MB implies OM is perpendicular to AB, which means this angle will be 90 degrees. Let us see the proving. See, I'll draw two triangles. Look at triangle OAM and triangle OBM. OB is equal to OA, no doubt in that. Why? The radius of a circle. OM equals to OM equals to OM, that's common if you see. Okay, then MB equals to AM, given. MB equals to MA rather, this is given, which means these two triangles, triangle OBM is congruent to triangle OAB, side. Now if these two triangles are congruent to each other, which means these two angles will be equal, CPCD, okay, which implies we have already done congruency, okay, you can go through the video and see, which implies angle OMA, I've written it wrong, OAM actually, yeah, see, angle OMA will be equal to OMB, okay, CPCT. Now if these two angles are equal, of course, suppose this is X and this is X, so X plus X will be 180 because linear pair, which means twice of X is 180, which means X is 90 degree. If this angle is 90 degree, we can say that OM is perpendicular to AB, and that is the theorem only, that if OM divides AB into two equal halves, okay, then OM will be perpendicular to AB. So that's the first theorem. I hope this is clear. Now let us see the converse of this theorem. Now let's see the converse of the theorem. What was the theorem? The straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular to the chord. Converse, that the perpendicular to the chord, which means if this is a circle, this is a chord AB, O is the center. If you drop a perpendicular on the chord AB, given, what is given to you? OM perpendicular to AB. The perpendicular to the chord from the center of the circle bisects the chord, which means if OM is perpendicular to AB, then it implies that AM is equal to MB, which is OM bisects AB. Okay, remember the theorem was if AB bisects, if OM bisects AB, then OM is perpendicular. Converse is if OM is perpendicular to AB, then OM bisects AB also. Let us see the proving. Same manner, see. We'll join OA and OB. Now, in triangle OAM and triangle OBM rather, we'll write OBM. Okay, OA is equal to OB, that's the radius for the circle, isn't it? OM is equal to OM, that's the common side. OMA, angle OMA is equal to OMB equals to 90 degree, that's given to us, which means triangle OAM is congruent to triangle OBM, and the reason is RHS, right angle, hypotenuse, and one of the side is equal. So these two triangles are congruent. Now if they are congruent, then AM will be equal to BM, CPC, which implies OM equals to, sorry, not OM, AM is equal to MB, which is nothing, this is CPCT, which means that OM bisects AB. Clear? So the converse is if OM is the perpendicular, then OM bisects AB. And the theorem was if OM bisects AB, then OM is perpendicular to AB. Am I clear? Now let us look at the next theorem. Now let us see the next theorem, which says that equal chords of a circle are equidistant from the center. What does it mean? It means if this is your circle, suppose, okay, and you have two chords, suppose A, B, and suppose C, D. Equal chords, which means AB is equal to CD. That is given to us. Okay, if these two chords are equal, equal chords of a circle are equidistant from the center, which means if O is the center, then if I drop a perpendicular OM and ON, equidistant means we are talking about the perpendicular distance, okay, from the center. So OM, so if you have two chords which are equal length, then if you measure the distance from the center, distance is the perpendicular distance, they will be same, which means if AB equals to CD, then OM will be equal to ON. Okay, see, equal chords of a circle are equidistant from the center. This is given to us. We need to prove this. Let us see the proving. What I'll do, again, I'll draw triangles. Triangle AOM, triangle AOM, and triangle CON. Just look at this. Wait. OA is equal to OC. That's the radius, if you see carefully. Okay. OMA, angle OMA, and ONC, angle ONC will be equal, that is 90 degree. That is given to us. Distance, when you are talking about, we are talking about perpendicular distance, okay? Given. Now just look over here. First of all, AB is equal to CN. Just look over here. AB is equal to CD, sorry. AB is equal to CD. Since OM is perpendicular to AB, then we just did the theorem, okay, that AM will be equal to MB, no doubt. Again, ON is perpendicular to CD, which means CN will be equal to ND. There's no doubt in that, because the perpendicular from the center divides the chord into two equal half, the first theorem only. So CN and ND will be equal. Okay. Now look, since AB and CD are equal, we can say that AM is equal to MB will be equal to CN will be equal to ND, isn't it? Which means this distance, this distance, this distance, this, they all will be same. AM, MB, CN, ND will be same. Now, first point, second point. We just got the third point, that AM, see, AM is equal to CN. Just true. Isn't it? Try to imagine, suppose AB is 6, then CD is 6. Isn't it? Then OM bisects AB into two equal half. So this becomes AM becomes 3, MB becomes 3. Similarly, CN becomes 3 and D becomes 3. Which means all AM, MB, CN and D are equal in length. Okay. Now see, this was 90 degree. So we can say that triangle AOM is congruent to triangle CON RHS, because this is 90 degree. Hypotenuse and one of the side is equal. Now, if these two triangles are congruent, then you can say that OM equals to ON, OM equals to ON, CPCD. And this is what we are supposed to prove, that OM equals to ON, which means the distance from the center to these two equal chords has to be same. That is the theorem. Now let us look at the converse of this theorem. Now look at the converse of the theorem. The theorem says that equal chords of a circle are equidistant from the circle. Okay, just reverse it, you'll get the converse. That chords of a circle that are equidistant from the center of the circle are equal in length, which means if this is your circle, if there are two chords, suppose A, B, C, D, and the distance from the center is same, which means what is given? If OM equals to ON, and of course distance means perpendicular distance we are talking about, then AB is equal to CD. The reverse, earlier it was AB equals to CD, then OM equals to ON. Now it is if OM and ON are equal, then the length of the chord will be equal. Let us see the proving. Similar way, just draw two triangles. Okay, look at this. Triangle AOM and triangle CON. Just look. AO equals to CO, no doubt. This is the radius, isn't it? Then OM equals to ON, that is given to us. And OM and ON are perpendicular, that we know, that is also given. Angle OMA is equal to angle ONC. This is also given to us, which means if you look carefully, triangle AOM is congruent to triangle CON. Why? CP, CT. And if they are congruent, then AM will be equal to CN, which implies AM equals to CN. Till now any problem? So this and this are equal in length. Now look carefully. OM is perpendicular to AB. So the first theorem, you know, that AM will be equal to MB. Am I clear or not? Which means AB will be twice of AM, I can write. Similarly, look, ON is perpendicular to CD, which means by the first theorem, CN will be equal to ND, which means CD will be twice of CN, no doubt in that. And CN and AM are equal, so can I write CD equals to twice AM? Look, compare these two, simply means AB equals to CD, which means if the distance between two chords from the center, if you calculate, are equal, then the length of the two chords are also equal. We just need to prove congruency. Clear? Now look at one more thing. Okay, now look at this theorem, which says there is one and only one circle passing through three given non-collinear points, which means if I take suppose A, B, suppose C. These are three non-collinear points. Non-collinear points means they do not lie in a same straight line. Okay, if you draw a line, you can join AB, but you can't join A, B and C together in one single line. So they are non-collinear. Now they are telling that you can draw only one circle passing through these 3 points. You can't draw more than one circle. Let us see how. Okay, what I'll do, I'll join AB and CB. So A, B, C are 3 given, suppose non-collinear points. What I did? Join AB and BC. Now draw perpendicular bisector of AB and BC. Now suppose I draw, we all know how to draw the perpendicular bisector. From A you make an arc up and down, from B you make an arc up and down. Then suppose this is the perpendicular bisector, okay, of AB. Similarly we draw the perpendicular bisector of suppose BC. Suppose we get something like this. So XY is the perpendicular bisector of AB. XY is the perpendicular bisector of AB, and IJ, suppose I take IJ, perpendicular bisector of CB. Both the perpendicular bisector meet at a point, suppose that's O. Let O be the point of intersection of the two perpendicular bisectors. So we had those 3 collinear points, non-collinear points rather, sorry. We joined AB and BC. We drew the perpendicular bisector. Now one thing which you should know before proceeding, that if you take a line segment, draw perpendicular bisector on it, you take any point on the perpendicular bisector. Suppose I take this point as I, then this and this length will be same, IM and IN will be same. Are you getting it? Any point on the perpendicular bisector, will be equidistant from the line segment. Am I clear? And the perpendicular bisector, of course, it bisects and divides the MN into 2 equal halves, which means, just look carefully, OA will be equal to OB and OB is equal to OC. I just told you, if you take a line segment MN, you draw the perpendicular bisector, then any point on that perpendicular bisector will be equidistant from M and N, which means IM and IN will be same. Okay, that's one of the theorem. We'll do that. The proving part is very easy. See, since it's a perpendicular bisector, this and this are equal. This is common. This is 90 degree. So side angle side. These two are congruent. So IM and IN are equal. Okay. So over here OA and OB are equal. OB and OC are equal. Which means, can I say OA is equal to OB is equal to OC? Now, if you draw a circle with center O and radius OA, then OB also becomes a radius. Suppose you draw a circle with center O and radius OA. O is your center. Then OB also becomes a radius. Then OC also becomes a radius. Which means the point B and C as well as A will lie on the circumference. Which means if you draw a circle now, see, something like this. So OA, OB and OC are same. The three are the radius. So A, B, C will lie on the same circle. That is the theorem only. That there is one and only one circle passing through three given non-collinear points. Am I clear? Now let us look at three outcomes which you can use in the sum from these theorem. Okay? Now look at these outcomes. Now the first one, in a plane of a circle, so in a circle, the perpendicular bisector of the chord, if you take a chord, if you draw the perpendicular bisector of the chord, suppose A, B, suppose C, and AC is equal to CB, and MC is perpendicular to AB. In a plane of a circle, the perpendicular bisector of a chord passes through its center, which means this MN will pass through the center. This means somewhere the center is suppose over here. So O, the center, will lie on the line MN. Am I clear? This relates to the first theorem, Now, the second one, the perpendicular bisector of two chords of a circle intersect at the center of the circle. Just the extension of this, If, suppose this is one chord, the perpendicular bisector definitely will pass through the center. No doubt in that. Suppose you take another chord, suppose, and you draw the perpendicular bisector, then it also passes through the center, which means the two perpendicular bisector intersect each other at the center of the circle. And the last one, as there is one and only one circle passing through three non-collinear points, two different circles can meet at most in two different points, which means, see, if you take a circle, you take 3 points A, B, C. Then you can't draw another circle which passes again through A, B and C. At most what you can do? You can do another circle which passes through AB or BC or AC like this. So at most 2 points they will intersect, not 3. With 3 points, non-collinear points, you have only one circle possible. So these were the theorems and the outcomes which we need to remember, okay, before we start the exercise. In this video, keep it till here. In the next video, we'll see the sums based on this. Till then, take care.